Hello, everyone. So I'm going to introduce how to use and compare DBSCAN and K-means method for students' placement in the writing program. Background information and the purpose of the model. So the writing program at U of A offers a series of 3 foundational writing classes, English 106, 107, and 108 for international students. These courses are structured into a progressive sequence, moving from very basic to intermediate and advanced levels. And all international students will be evaluated and be placed into one of the classes. However, recently, many students expressed that their classes were too easy or too hard for them. Students with widely varying TOEFL scores, both very high or very low, can be and often in the same class. The writing program is working on refine the evaluation system. And this project will use both K-means and DBSCAN's clustering algorithms to group students and help place them into different classes based on their backgrounds. And they both have their own strengths and weaknesses. And this project will apply and compare both algorithms for the same purpose. How this topic relates to any of the topics in the class. So first, both DBSCANs and K-means are unsupervised learning techniques for data exploration. In unsupervised learning, the algorithm works with unlabeled data, aiming to find pattern, feature, and similarities within the data without any predefined labels. For K-means and the K-means they both are clustering methods. And the main difference is how they initialize cluster centers. For K-means, it can randomly choose the initial contrails from the data size. And for K-means it uses smarter methods to spread out the initial centroids and leads to faster convergence and potential better clustering results. And in this project, both students were from 3 different classes. However, the placement was not perfect and was not the model. Students have very different language and educational backgrounds. And so the method of using 3 classes as predefined labels for placement may not practical and not appropriate in this project. Therefore, this project used unsupervised learning techniques to clustering unsupervised data. In this project, I will use and compare K-means and DBSCAN in students' placement. I have 3 metadata spreadsheets for students from English 106, 107, and 108, respectively. They contain students' background information, such as their preferred name, gender, birth country, college, and major, multiple test scores, and etc. And I will group students based on 4 very important variables: their academic level with their academic year, college, and birth country code, and test scores, including TOEFL, IELTS, Duolingo, and CEPT. So let's take a look at the real worked example in R. So here it is. For the first step, because I have 3 metadata spreadsheets, and I would like to stack every spreadsheet into one whole file. So this one is to stack 3 files into one file. And then next, I want to keep the important elements. So just to keep the column that I want. I will keep the student's ID, their academic level, college, birth country code and multiple test scores here. And next, I would like to simplify the column name and then normalize the scores. So because students can take different tests, and for each test, they have different full scores. For TOEFL, the full scores are 120, and for IELTS, the full score is 9. Duolingo is 160, and CEPT can be 150. So I need to normalize the scores. And the next, I would like to get the average score as a new column, because some students took one specific test, some students took 2 tests or multiple tests. So in this case, I need to get an average score and add a new column. And the next, convert string to number for computation. And you can see this is the result. I convert everything into number. And next step is to use k-means to cluster this data set. You can see I set the center, the cluster as 3 because we have 3 different classes. So I just want to cluster all students into 3 groups. And other parameters keep as default. And then next, I would like to create a new column to see which cluster the student is in. So you can see the result. This column shows which students in which cluster. And we have 3 clusters, some of them in the first one, second one, or third one. And next step is to use DBSCAN to cluster the dataset again. For DBSCAN, there's no specific way to control the number of the cluster. So I need to change the parameter value and then try to narrow down the cluster into 3 clusters. However, I changed the multiple numbers. I can get 4 clusters in total, and I cannot lower it down to 3. And you can see this is the result. And then after that, I use ggplot tool to view the country and score relationship. And you can see from the picture for k-means it creates 3 clusters and is heavily related to the students' birth country, their original country. So for example, if the group of students are from the same country, they will definitely be placed in the same cluster. So in this case, I think k-means is heavily relay on the birth country of the students. And similar to DBSCAN, so you can see from this picture, if students from the same country, they probably be assigned into the same cluster, although there are some exceptions, but there for DBSCAN, it is also highly rely on the student's birth country. And next one is the relationship between the academic level and their scores. For k-means, as we can see, there are 3 clusters. For sophomore students, some of them are in this first cluster. And for freshmen, some of them in the first cluster, some of them in the third cluster. Similar result in DBSCAN. We have a lot of population in the freshman year, and some of them in the second cluster, some of them in the fourth cluster. And then going down, this is the relationship between college and score. And as we can see, students from College of Science, College of Social Science, Social and Behavior Science, Eller College of Management. There are a lot of students from those college goes to the second cluster. And for K-means plus, some of them, a lot of students from the three college, they go to the first cluster. And some of them from the College of Science, they have been assigned to the third cluster. Yep. And next one is the score in the cluster. So for DBSCAN, we can see we have 4 classes, and the average score of each cluster is kind of random. There's no specific trend for the 3 clusters. However, for K-means plus, we have 3 clusters, 3 classes, and the average score of each class is increased a little bit. So it's a reasonable increasing trend, increasing average score trend. So yeah, that's everything. For the conclusion, as we can see from the ggplot, K-means plus can create 3 clusters for 3 classes, and DBSCAN always creates 4 clusters, and it's hard to control the number of the cluster. K-means plus may be more suitable for 3 class placement. And for both K-means plus and DBSCAN, the cluster groups heavily depend on their birth countries. And for the distribution of scores by clusters, K-means algorithm shows the average score for each cluster have an increased trend along the sequence of the course. It looks more reasonable. And for the future steps or recommendations, so for 3 class placement, K-means plus can be more appropriate as it allows us to control the number of the cluster. And for both DBSCAN and K-means plus, they reveal a strong relationship between the clusters and the students' original countries. There's a need to have a deeper investigating into the strategies for effectively balancing different variables. Yeah, that's everything. Thank you for your listening, and feel free to give me any feedback. Thank you so much.